So, hi everyone. Let Just give me a couple of minutes. Let me, okay. Yeah. Let me share my screen. Yeah. Yeah. So yeah. Hi everyone. Hope you are all doing well. Uh, we had to reschedule this workshop a couple of times because of some problems. But yeah, glad we are here again. Um, this will be a very short workshop. Recently, I started working on a new project which has lot of data visualizations, uh, and this is the first time I started working on a data visualizations. Before that, I worked on lot of React-based projects, lot of big React-based projects, but this is the first time where I need to work on lot of data visualizations. And when I am starting this project, I had to do a lot of research on which libraries to use, how to go about implementing data visualizations in a React project. I thought this would be a good topic to share, so that's the reason I scheduled this workshop. Yeah, this will be very short, more than demos. I will walk you through different kinds of libraries that are available, which we can use for implementing data visualizations. Um, and if you have any questions or if you want any clarifications, feel free to ask them anytime. Okay. Um, yeah. So let's get started then. Um, just to get started, just the basic introduction of what is data visualizations. Uh, Data visualization is a graphical representation of information and data using elements like charts, graphs, and maps. And we see them a lot, right? Especially when we want to visualize a lot of data. I think charts and graphs will be very helpful. For example, let's take this coronavirus thing, which because we are dealing with this from last 2 years, right? And so this is a chart. When we look at it, just by looking at it within a single glance, we can understand that hey, we have three peaks of coronavirus. First one happened between July and December, and the second peak happened during the May, and the third peak happened in January. And we were able to kind of get to some conclusion, or kind of understand the trends and patterns of the data very quickly. When we see an image, people say, one image was 1,000 words. If you were to look at the same data in a tabular form, if you were to look the coronavirus cases data for last 2 years data in a tabular form, then we have to scroll a lot, and we have to see them, and we miss lot of details when we are reading the data in a tabular form. And when we are reading the numbers, we might miss lot of information. Tables have some its own place. Especially it will be very useful when we have like very small amount of data. If we have like 3 or 4 rows of data, maybe table might be a good choice. But if we have like hundreds or thousands of rows of data, table might not be a good choice, because we have to scroll up and down. We have to try to understand what's happening, whether it's increasing, decreasing, what's the trend. It's hard to understand by looking at a table. That's where these data visualizations like charts and graphs will be very helpful, because we can understand huge set of data very quickly. And same thing goes to stock market charts, or anywhere you want to analyze huge sets of data. I think charts and graphs will be very helpful in analytics, stocks, finance, uh, anywhere the data is there. Yeah, as I said, recently I started working on a project which need lot of visualization because it has like lot of data, and we need to visualize and analyze that data. And when we are starting this project, we have to go through this exercise of deciding on which library to use for implementing this data visualizations. So I did a lot of research, and I kind of explored a lot of libraries that are available, and try out a little bit of different libraries, and finally chose one library. So I will walk you through the different libraries I explored, and the kind of things I understood while this exploration. Okay. Uh, if you are coming into data visualizations, you will be definitely hearing a lot about D3, because D3 is kind of the most popular data visualization library out there. And uh, on top of D3, there are a lot of tools developed. So there will be like a lot of wrappers on top of D3, like C3, DC, and so on and so forth. And because D3 is kind of JavaScript, core JavaScript, it's not tied to any framework. But especially when we are working with a React project, there are some wrappers on top of D3 which were more React friendly. So there are some React wrappers on top of D3. So we can take a look at some of those as well. And there are some other libraries which are config driven, where D3 is kind of more code driven. We have to write a lot of code to implement the data visualizations, but there are certain config driven libraries where we pass the configuration, and based on the configuration the library will give us the charts and graphs, and we can look into a couple of those libraries as well. Finally, we will look into AntV, which is uh, visualization library coming from the Ant Design group. Okay. Okay. So the first and foremost one is D3. D3 is the well-established data visualization library, and it has a like large community. And uh, a good thing about D3 is it provides low-level API to build almost any data visualization we need. In the sense, if you use D3, you can build almost any data visualization you need. There is no limit, just that you need to put a lot of effort, but no matter how complex it is or how strange your requirements are, you can implement them with D3. That's the positive thing about D3, because it provides the low level API. It provides the utility functions and the low level API. Based on that, we can build data visualizations, any data visualizations in it. The cons of that is, it doesn't provide, it only provides the low level API. It doesn't provide high level API. So it doesn't come with any out of the box support for basic charts. For example, let's say we want to build a basic bar chart, right? And even to get a basic bar chart in D3, you have to write a lot of code, right? And maybe you have to write 100 lines, 200 lines of the code, just to get the simple bar chart, you know um, because D3 is not built for any specific charts or any specific data visualizations. It provides kind of the low level APIs. Based using by leveraging those low level APIs, you can build any other higher level charts or graphs, but it doesn't come with any out of the box support. So which means that there will be a huge learning curve. You need to learn all the utilities, and you need to learn how to use those utilities the best way. There will be a lot of huge learning curve, and we also need to put a lot of effort. As I said, even just to implement a basic bar chart, we might need to write 100 lines of code. That means it takes more time. It takes more time to maintain, it takes more time to develop. Yeah, and it has huge learning curve as well. But since this is well established, and it supports, it helps us build complex data visualizations. A lot of companies use, for example, New York Times, Datadog, Coinbase, Square, all the fintech companies, and the public, the journalists. Because for example, New York Times have like a lot of complex data visualizations, especially when they want to do election forecasting or want to represent complex data in a to show the news and everything. They use D3 because they have like very unique requirements. For them, the basic chart components might not be sufficient, because they want to represent very complex sets of data. They might want to customize uh, the charts to the maximum, and for them, D3 will be much more suitable. uh, yeah, let's take a simple, the way I want to do is, I want to walk you through different libraries, and I also want to show uh, code for a bar chart. I took bar chart as a baseline like a to do application for different frameworks, right? I took bar chart as a reference for different libraries, and I will show you the code for a bar chart for different libraries so that you can see the difference. What it takes to build a bar chart in DZ, what it takes to build a bar chart in Antv, and so on and so forth. You can kind of take a look at the comparisons. Okay, so yeah, so the design and consistency is not there, but just I want to show the basic examples. So yeah, so this is a basic bar chart implemented in D3. Nothing fancy. We have like some x-axis, we have y-axis, and we have some bars. Let's see what it takes to implement that. Yeah. Um, Again, since I'm representing or presenting in a React app, I'm using refs here because this D3 is kind of renders into a DOM node, right? It's not D3 is not a React library, right? We should give a reference node to this D3, and on top of that, D3 will take over and render. Okay, so for that, I created an empty div and passed a ref, and I will pass this ref to a function called render bar chart. And inside this render bar chart, I will use D3 to draw that bar chart on this particular node. So D3 will take care of rendering bar chart on this DOM node, right? So let's see the code for this thing. So as I said, D3 provides just the low level um, APIs. It doesn't. For example, if you want to bar chart, you know, uh, D3 doesn't know about it. What it does is it gives us some utilities like for data transformations, or for drawing the accesses. It gives some utilities, and we have to leverage those utilities, and plus D3 plus SVG, and kind of draw. You can you can almost think of drawing. For example, we have to first create a SVG element, right? And we are passing the element whatever ref we passed here, right? So we are passing that to the select, and we are creating an SVG and appending to that particular element. And for that SVG, we are setting the width, we are setting the height, and we are appending G. G is kind of the graphic element of SVG. And then we are deciding on the x-axis. What is kind of the range of the x-axis. What are the data points of the x-axis. We are Again, these are D3 dot scale band is kind of the utilities coming from the D3. And once we decide on the data transformations and what data to show on the x-axis, right? Then we have to actually draw the x-axis, right? So we have an SVG element created above. Now we are appending, and again, D3 has some utilities to help us. It returns the data necessary for drawing the x-axis, either the ticks or those things. And based on that, we are drawing those x-axis. This logic, even I'm not 100% sure about the specifics, but this piece of code is for drawing the x-axis. Let's see. Yeah, so we have this x-axis, right? We have the country names, and we have those ticks. This piece of code is doing that. And then again, the same thing for the y-axis. We decide on what is the range. It starts from 0 to 1300. That's what we are doing. D3 dots scale linear, and we are saying that we have the range of we have the domain, the values ranges. from 0 to 1300. And yeah, the range is kind of the amount of height the y-axis takes. And again, once we do the calculations, then we will transform that calculations into an SVG element, right? So this piece of code will draw the y-axis. Now we have x-axis and y-axis. Now we have to draw the bars actually. Again, the bars are again the rect elements coming from the SVG. So as you can see, right, even just this basic bar chart, we have to draw the x-axis, we have to draw the y-axis, we have to draw the bars. And if you want to add some sort of show some tool tips, or if you want to do some animations, we have to write more code. As you can see, things get really complex very easily, because we are this is the kind of the code which we don't like writing as a React developers, right? This looks very declarative in the sense, but unfortunately, that's how D3 works. We can improve a little bit by writing some abstractions, but again, that's not the standard way of doing, in D3. If you are just using D3, it looks more declarative. Then we can kind of build separate components. For example, for x-axis I can write a component, and for y-axis I can write a component. For bars I can write a component. I can build some abstractions, some React abstractions on top of these things. um, yeah, we'll look into those things as well. There are some React wrappers when we are discussing that, So those libraries exactly do that. They abstract this whatever we are doing here, the way we are writing the HHs, bars, and everything, right? The React wrappers abstract this logic into separate components and provide them as a components to us, so that we can use them. So those libraries will be slightly easier than using the D3 directly. If you use D3 directly, it will be like very, you know, not very declarative. It will be like imperative. First we have to draw x-axis, then we have to draw y-axis, and so on and so forth. Yeah, sure. I will share the slides at the end. I hope you can see my code as well. Okay. Okay. So, do you have any questions on D3 so far? Okay. As I said, D3 provides a lower level API, and we might need we might need to put a lot of effort to implement even the basic things like bar charts. But it has its place in the sense, if you want to build very customized, very complex data visualizations, uh, and even if you are ready to put in the effort, maybe D3 might be your choice. And then there are other set of libraries called D3 wrappers, in the sense, since implementing everything directly on D3 is hard, there are some libraries built on top of D3 to make things easy. For example, we'll have some utility functions for making bar charts easily, right? Two such libraries are C3 and DC.js. There are few other libraries. So the advantage of these libraries is, we can get the best of the both worlds, in the sense, we can use C3 and DC.js to implement the basic things like, bar charts and pie charts and everything. They'll have some utility functions already, so we can use them to easily implement the basic charts. And when we need some very complex data visualizations, because these libraries are still built on top of D3, right? So we can, at any time, we can drop down to D3 and use both D3 and these libraries. For example, if we are building a basic bar chart, we can build the basic bar chart using C3, but on top of that bar chart, if you want to do some special things, for those special things, you can use D3. Yeah, let's see a simple example for DC. And again, this is very simple bar chart. The code here for DC, you can see it's slightly smaller compared to the previous one. Again, we are using refs. Again, we have to create a div and pass a ref to that. And pass that reference element to this DC, and yeah, here we have a bar chart component which is coming from DC, right? We create a bar chart component, and again DC depends on another library called cross filters for data transformations, which again has some learning curve. But yeah, but at least here, right? We created a bar chart. We have passed in element to this bar chart. We created a chart, and here we are setting the width, we are setting the height, and we are passing the data. um, we are passing the scale for the x-axis, we are passing the data, and so it's kind of, at least here with DC we are not drawing the x-axis, we are not drawing the y-axis, we are not drawing the rectangles, right? We are not working with the core elements, we are kind of working one abstraction above the basic SVG elements. So in that way this library is better, but still it's not very easy, in the sense, we have to use cross filters for these data transformations. Even this dimension and group, they're slightly complex to understand, and that's with the DC. There is another library called c3.js, which is slightly easier than, um, sorry, okay, okay. um, Yeah, which is slightly easier than DC, in the sense, at least here we can directly pass the data, and without, we don't need to use cross filters, uh, and we can just say our data one is of type bar, and yeah, it's slightly easier compared to DC. But again, since these are the pure JavaScript components, we have to go through this process of using use effects, using React refs, and passing these React refs to that particular C3 C3 functions. We have to do all these things. Let's see what better we can do. This is the chart drawn with the uh, C3. Next, we have React wrappers on top of D3. Some of the libraries are Nivo, Rechards, VS, React Vs. There are like several libraries. These are the kind of the most popular ones, and even within these things, they have like some limitations. For example, I guess React Vs is not well maintained. I guess recently, Rechards and Nivo is popular. But Rechards only works with SVGs, but Nivo works both with SVGs and Canvas. So there are some trade-offs, but we'll mostly look into Nuvo because that's kind of the much more full-fledged. Uh, and let's see how we can use Nuvo. Again, as I said, even this Nuvo is built on top of D3. And again, as I said, these libraries like Nuvo, which are React wrappers built on top of D3, make it easy for us to work with uh, React. So as I said, this is much better than the previous examples I have shown, right? We have a bar component coming from Nuvo bar, and which kind of abstracted all the logic, right? With the for this bar, we are passing the data, we are passing the keys, which we keys is kind of the data which we want to show on the y-axis. Index by is kind of the uh, metric which we want to show on the x-axis. We are passing the width of the bar chart, we are passing the height of the bar chart. This is much easier to work with, right? First, Nuvo is providing us the basic chart components which we might generally need, and it is also making it very easy for us to use. Let's see a demo with the Nuvo. Yeah, so this is very basic example. Again, here also we can leverage Nuvo to use to implement the basic charts, and when we need heavy customization, right? Since Nuvo is built on top of D3, we can drop down to D3 level and implement the customizations. Wherever Nuvo works, we can use. When for some special features Nivo doesn't work, then we can drop down to D3 and use them. Yeah. So what else? Yeah, in the same way, the whatever example I have shown is for Nivo. In the same way, Recharts, VS, Reactvis mostly works in the similar fashion. Their API might be different, but yeah. And you can see with Nivo, you can do quite interesting. Okay, let me not open here. Yeah, as you can see with Nivo, we can do lot of customizations, and we can do a lot of interesting charts. This is kind of stacked bar chart. Previously we have just seen bar chart for a single set of data, right? So here we can see uh, bar chart which shows different sets of data, and here it has line charts, multiple line charts, and this kind of a grid kind of things. It has this radial pie charts kind of thing. It supports wide variety of charts, and it also styling also looks good. And it also has like different parameters which we can customize, maybe the colors, and it provides quite interesting sets of customizations as well. Yeah, so that's with the React wrappers. Next, we can take a look at the config-driven libraries like eCharts and HighCharts. Um, the advantage with these things are they come with out-of-the-box support for commonly used charts, and they are also highly customizable. We'll see an example. The problem with this kind of libraries is they don't provide low-level API. For example, with eCharts, we can do wide variety of charts and graphs with eCharts, but for some reason, if you have a very special, unique requirement which is not supported by eChart, you might not be able to implement with eChart, because it doesn't provide any low level API. It just takes the configuration, and based on that configuration it renders the chart. That's all. It doesn't provide any low level API, so that might be a limitation. But you can see some examples as well. For example, um, yeah, before looking at the demos, let's see how to implement a basic bar chart with eChart. Again, high charts is also very similar to eCharts. The only drawback with high charts is it has kind of a different license, in the sense it's not free for commercial use, I guess. It has some licensing issue. Whereas this eCharts is an Apache Foundation project, and it's kind of free for both personal and commercial use. Whereas I guess high charts is free for personal use, but we need to take a license for commercial use, I guess. So there is some licensing issue with high charts. But both tools are very customizable, and they support wide variety of uh, charts and graphs. So let's see how to build a basic bar chart with each charts. Um, again, as I said, it's config driven. Again, since eCharts is not a React library, we have to use this ref thing. We have to create a ref and pass this ref to this function. And inside this function, we create a configuration object. Here we are saying on the x-axis we have this uh, Monday, Tuesday, Wednesday, days of the week, and y-axis. Okay, on this we want to show a bar chart, and on the bar chart we have 7 data, because on the x-axis we have 7 points, so we are providing 7 sets of data, right? So, and this is the configuration, and we just init in each chart with the width and height and the element. We get a chart object, and on top of that object we set in the configuration options which we created. So let's see how it looks. Yeah, it's also quite easy, right? And it supports not just the basic. bar charts, but it kind of supports wide variety of charts, and it's very customizable as well. Let's take one example, um, one complex example. Yeah, it supports these bar charts, radial charts, even the scatter charts and everything. So the interesting thing is, no matter you can see here we have the four scattered charts here, right? Even this is entirely config driven in the sense, there won't be any much code at all. In the sense, maybe the code is to transform the data, but at the end we just pass the configuration. You know, for example, what kind of zoom you want, or what kind of grid layout you want. Everything is config driven. Maybe you will pass some code for event handlers kind of thing, but yeah, mostly it's kind of config driven. If we want to see one more example, let's take a look at this kind of maybe pie chart. Yeah, again, as I said, here we just see the option, right? It has a title, it has a tooltip. Tooltip is what appears on top of the, when we hover, right? The tooltip, or what is the trigger for the tooltip. Legend is kind of these kind of, the colored things which shows, for example, the red means union ads, yellow means email. So this is the legend, right? And the series is the actual data, right? As you can see here, there is no code at all. We are writing this option, which the e-charts will take this option and give us this chart. And again, so based on the for example, here we are saying type is equal to pi, and the radius is equal to 50%, and this is the data. And based on these configuration options, e-charts will kind of give us this data visualizations. And yeah, as you can see, it's not just the basic charts. It has like wide variety of as you can see in the examples, it provide wide variety and much very complex as well. For example, some of the charts we are seeing here are like very complex. For example, even the annotations on this, you know on this cow, or on the human being. So on the these maps, right? These are quite complex, and e-charts will support us. Again, the mostly it is config driven. The only downside with this is whatever e-chart supports, we can use leverage it. But if for some reason, if we have a very special requirement and which is not supported by the e-charts, you can't implement it, right? Uh, yeah, that's the trade-off you have to do. You might implement by writing much more complex code, by manipulating the DOMs and everything, but it's hard because it's not the official way of doing it. Would be like very hard. There won't be any official documentation or official help on how to do that. Yeah, but it's because it supports wide variety of configurations. For most 90% of the use cases, those will be sufficient. For example, GitLabs wrote a blog post on why they are moving away from other charting library to eCharts, and how they saved so much time with eCharts. They wrote a great blog post about that. You can take a look at it, and a lot of companies use eCharts, right? Yeah, and the final version is AntV. So AntV is kind of an Ant Vision, which is coming from the same team as Ant Design. You must be familiar with Ant Design, right? And that's one of the popular UI React component library, and especially it is used for building enterprise or SaaS or dashboard kind of applications. Mostly people use Ant Design because it has kind of an entire tool chain, in the sense it has a design kit, it has components, and it has layouts specially tuned for dashboards. And of course this charts, right? Again for enterprise applications and for dashboards, charts are very crucial. I think that could be one of the reason where they build this entire tool chain of for charts. Um, so if you are using AntV, you can easily use this with AntDesign. Of course, you can use it with any project, but since it is coming from the AntDesign, there will be some much easier interpolation. Yeah, and so the thing with AntV is it's not just a single tool. It kind of contains layers of tools. For example, so far we have seen three layers of tools, right? For example, we have seen D3, and on top of D3 we have seen some wrappers of D3, for example DC and C3, and on top of, not on top of, but we have seen the third layer, which is called React wrappers, to make it easy to use. So we almost have like three layers, right? We have D3 and another layer like DC, and on top of that we have another layer for to making it easy with React projects. In the same way, and we also has multiple layers in the sense. At the lower level, it has something called G2. Uh, G2 is kind of you can think of G2, which is equivalent to D3. It kind of contains the lower level, semantics for data visualizations. On top of G2, there is another library called G2 plot. G2 plot, you can think of something similar to DC or C3JS. It contains all the commonly used chart components, for example, bar chart, pie chart, whatever we have seen with e-charts and right, everything. Those things are readily available with G2 plot. At the G2 level, it contains just the basic grammar for data visualizations, but with G2 plot, we have the some higher level abstractions on top of G2, which make it very easy for us to build the standard charts. And on top of G2 plot, we have this and design charts, which will make it very easy for us to use it in React projects, right? So we have like uh, three projects. So the only downside with this I have seen is, that because this and design and and they are coming from the Chinese companies. I think Alipay is behind this, the development of this thing. But since and this is very heavily used in China. A lot of companies in China use it. Outside China, also a lot of companies use that. But since this is coming from the team which is located in China, their documentations tend to be in Chinese, and when we click on the documentation or something, then we will get a pop-up, Google Translate pop-up, saying that, do you want to read this in Chinese or do you want to read this in English? Then you choose English, then it will translate to um, English. So mostly the documentation is good, but you have to go through these hoops of using the Google Translate. Sometimes in the demos, the data and everything will be in the Chinese language, not in English. So there is some trouble with that, but otherwise, you know, uh, from the feature perspective, it's really good. Anti is really good, and it's used by a lot of other companies also, especially since this is part of and design. And I think if you are already using and design, and if you need some charting libraries, I think this would be a really good choice. uh, yeah, let's see some code for Antv as well. Again, as I said, this has some different layers. uh, Again, this the code with the AntV and design charts will be as easy as Nevo, right? Because in the Nevo also we imported a bar component, we have the data, and we passed the configuration in the sense. I think that also has a similar API. We pass the X field, which is the X-axis data property, and Y field, which is a Y-axis data property. In this case, it's price, and we are passing the data, and column is the column chart. Let's see a demo. Yeah, again, this is a basic column chart. um, yeah, as you can see, so the advantage with this thing is, for the basic things we can directly use this React way of importing components and just passing the configuration. And these components are called and design charts, right? And if this doesn't work, if you want to some implement some advanced features which is not supported by this, we can go one level down and use gt plot. And If that also doesn't work, we can go one more level down and we can use G2, right? So we have this hierarchy. Let's see. Again, the interesting thing with this and design charts is it's not just a single tool, it's kind of full uh, suite of tools. For example, even the data visualizations, right? I was talking mostly about G2 and G2 plot because mostly we were talking in terms of charts and graphs, right? But there are other things as well. For example, L7 is used for geo. For example, let's say you have a map, and on top of the map, you want to show some sort of maybe population metrics or GDP metric or something, right? Based on the uh, a chart. So that's where the L7 will be used. I think SS is for flow diagrams, I guess. The data visualizations is kind of very vast field, right? It can be like wide variety of things. It can be charts, it can be graphs, it can be maps, it can be flow charts. And we has tools for each one of them. For example, G2 is for charts. L7 is for geospatial data, right? This axis and flow is for I guess it's for flowcharts, so on and so forth. And these are the core libraries which are pure JavaScript libraries, all this G2 and G2 plot. And on top of that, they have some React abstractions. For example, previously we have seen this plots which is coming from React component, right? Um yeah, I was talking about this component, the column component, which is coming from and design plots. So they have React wrappers on top of this core lib and P libraries. Yeah, again, these libraries are much flexible in the sense, they can render both to Canvas and SVG and WebGL also. For example, especially when you are working with geospatial data like maps and everything, you know, rendering to WebGL could be a much better option. Uh, yeah, so. We explored kind of when we started this project, right? We kind of explored all these libraries, D3, DC, Nuvo, and Antv, and finally we chose Antv because for various reasons. Uh, as I said, our project is highly we need highly customizable data visualizations because our project has a lot of intensive data visualizations. The basic chart components which comes out of each charts might not be sufficient for us. So we want to have these basic things like bar charts and pie charts, but on top of that, we want to implement a lot of customizations. So something like e charts might not work for us because we need a lot of customizations. And D3 is also not suitable for us because, as I said, it has a lot of learning curve. Even with Nivo, even Nivo provides a lot of basic charts, but when we want to do customizations, we have to go to the level of D3, and again, D3 has a lot of learning curve. Compared to D3, I feel that G2 has much better abstractions and much easier abstractions to work with. Uh, so we thought Ant V will be a much good choice. And another thing is it's coming from the Ant design group, right? In our project, again, our project is a SaaS project, and it's kind of we are using Ant design in it. And since this Ant V is coming from Ant design team itself, we thought, okay, both are coming from the same team. It will be much easier for us to use the tool chain which is coming from the same team. So that's also one of the reasons why we chose Ant V. And the third reason is the entire tool chain, let it be the React components or the low level components. Again, as I said, since we have like a lot of customizations, since we need a lot of customizations, for us React components might not be, for example, the components coming from and design plots might not be useful for us all the time. We want to do some customizations. In that case, we will fall back to the lower levels like G2 plot or G2, right? And all these tools are coming from the same team, right? G2, G2 plot, and design charts, entire stack of data visualization tools are coming from the same team. uh, so there will be some sort of consistency there as well. Unlike D3 and Nuvo, D3 is from a different uh, team and Nuvo is from a different team. um, so we thought this this thing will be much more friendly for us. You know, these are some of the reasons why we chose Antwi. And also, like, our designers are using the Ant design language, and when we looked at the designs for the data visualization, and when we looked at the demos provided by the Antwi team, we thought, okay, it will be much easier for us to implement with whatever data visualization which we need to implement it. It will be much easier for us to implement with Antwi compared to uh, Nuvo or something, because our designers are following the design language of Ant design. uh, so yeah, obviously Antwi and Ant design will have similar design language, so it will be much easier for us to implement charts with Antwi. And we tried, and we started using Antwi in our project, and so far it's working out pretty well. And we were able to implement quite complex data visualizations as well. So far we were happy with some with Antwi. As I said again, the only problem we faced with kind of find of resources, and kind of trying to look into the documentation, find that it's in Chinese, we have to convert into English. So that's the only downside we found, but so far we were happy with that. Of course, as we go forward, we do more exploration and make sure it is working for us. But so far, we are happy with this. And yeah, any questions so far? Yeah, feel free to. Yeah, feel free to drop any questions in the comments if you have any. Yeah. Okay. Again, as I said, we chose Antwi, but what would you choose? Your situation might be different from us, right? But as I said, we are already using Ant design, and we prefer Ant design. So for us, going with Antwi, and also some of the other reasons I mentioned, Antwi is our choice. But does that apply to you? Again, it depends, right? For example, eCharts is really good library in the sense, it didn't work, it might not work for us, but it might work for you. We never know, right? For example, if we have mostly standardized charts, in the sense, for example, if you want to do some analytics, if you want to build some data visualization for analytics, you mostly need some standard charts, right? And maybe you can take a look at eCharts and see if whatever configuration, whatever options they provide is suitable for you. And if it works, then obviously eCharts will be much better solution, because you don't need to worry about writing any code or anything. You can try out the options provided by the eCharts, and if it works, yeah, it's very good. And it's also, eCharts is also really good library, and it provides a lot of customization. For example, you can change the colors and everything. The only downside is you can't implement heavy customizations. If if uh, standard charts are not your choice, in the sense, if you need heavy customizations, then eChart might not work. And if you prefer D3, then Nuvo might be a easier solution, because Nuvo is a good abstraction on top of D3. As you have seen earlier in the demo, we can see that we were able to build the bar chart very easily, right? Just one component and pass some configuration, we were able to work with that. And Nuvo provide lot of different chart components, and lot of configuration as well. You know, uh, if you prefer D3, then I think you can go with Nuvo, and you can use the whatever standard components that come out of Nuvo. And when Nuvo doesn't work out, you can drop down to D3 and use Nuvo plus D3 to implement your special features. And if you prefer and we or if you prefer and design, then and design charts will be much better choice. Yeah, it's again comes down to the choice of the libraries, comes down to what kind of uh, requirements you have, how complex data visualizations you want to implement, and what are your preferences. Yeah, it's boiled down to the, in our case, so far for us, and we and design are working well. Yeah, I think Prasanna is asking about the native mobile chart libraries. I haven't tried that, to be honest. I'm so far mostly exploring different libraries on the web itself. I haven't explored the native site. I guess and we has, okay. Let me check. I think G Sheets. I think G Sheets and we is mobile friendly. I think. Let me check that. Yeah, I guess they have some native component, native as well. But so far, of course, some of these libraries will work on native mobile as well. They are mobile friendly as well, but they are not native in the sense, not written in native languages in the sense, they are not written in Swift. They are JavaScript libraries, so that's there to it. So to be honest, I haven't tried them with mobile that much. Currently, we are mostly exploring on web. Yeah. And so far we covered like we explored kind of different libraries, right? You can also take a look at this awesome website. It has more more options as well. For example, we didn't cover Chart.js. I think this is also popular. Uh, we didn't explore. I think this supports only SVG, so we didn't explore this. But yeah, it has a quite a big list of different charting libraries. You can take a look at these as well. So one more aspect of this I want to cover today is kind of where do we render these charts? So far we looked at different kinds of libraries, right? And where do we render these charts? Um so we can render these charts either to an SVG or a canvas, right? Both has pros and cons. We'll quickly look into that. So, for example, if we are rendering to the SVG, it will be much more responsive because SVG is kind of vector. It's made of a vector path. So when you resize the chart or something, it will adjust very easily, without re-rendering, because it's a that responsiveness is supported natively, and it also has better accessibility. The only problem with SVG is if we have like huge number of data points, the performance might be bad. For example, if you are trying to do a scattered chart with maybe 100K data points, or 10K, 20K data points, you know, creating so many elements. Again, on the web, the performance, it depends on the number of elements on the web page, right? If we are putting like 10,000 elements, especially SVG elements, the performance might be bad. Which is not the, because of the way the it renders, which is not the case in the canvas. I think canvas works really well for large data points. The downside with that canvas is, it's not responsive in the sense, if you change the size, the canvas doesn't automatically adjust to the new size. So it has to be redrawn sometimes. That's one drawback, and it's also not accessible as SVG. But if you have like huge number of data points, I guess canvas will be a much better choice. But if you don't have that many data points, for example, the bar charts, the pie charts, right? It has like at maths 10 elements, 20 elements, 30 elements, right? In maths 100 elements. In such cases, I guess SVG should be fine. But if you are going to have huge number of uh, data points, then canvas would be better choice. While choosing this data visualizations library, I think you should also see whether they support SVG or whether they support Canvas. Some libraries support both. For example, G2 support both rendering to SVG and it supports rendering to Canvas. For example, there will be an option where do you want to ever render target. You can give SVG and it renders to SVG, and if you can give Canvas, it renders to Canvas. G2 supports that both. Some libraries doesn't support. For example, some libraries only support Canvas. Some libraries only support SVG. That is something you have to look into. For example, let's say you started a project and if that library doesn't support Canvas and suddenly you have a data visualizations which requires like 10,000 data points, then maybe your performance will be bad with SVG. So while choosing the library, you have to be careful and make sure it supports both, so that in future you can switch between Canvas or SVG based on the requirements, right? But for simple cases, anything will be good. Like Canvas might work, SVG might work for basic cases. Yeah, and some of the best practices to follow is, because these data visualizations are like heavy data intensive, right? Because there will be like a lot of computations when you have a data and that need to be drawn into an image, right? There will be like a lot of data transformations either in your code or the library itself might be doing a lot of transformation. So it will be very compute intensive, and even drawing so many elements, right? That's a lot of work for the browser itself. So you shouldn't render any data visualizations which is not on the viewport. For example, let's say you you have like very big page and you have like 10 or 10 data visualizations. User might not be looking at all the 10 of them, right? So there is no point in rendering the data visualizations which are not in the viewpoint. When the user scrolls to that point, maybe you can then render the data visualizations. That way, for example, if you render all the data visualizations even though they are not in the viewport, so it will affect the performance, it will affect the scroll performance, it will affect the overall performance of the web page, because the page has like lot of elements, a lot of compute intensive, data visualizations, the performance of the entire page will be affected. So when some data visualizations are not there on the viewport, maybe you can just render a placeholder and reserve the width and height for the data visualizations and not render the data visualization itself. And when the user actually scroll to that particular position, then render the data visualizations. So that can be accomplished with libraries like React Virtualized or React Window. You can use such libraries and implement this kind of functionality. And also, yeah, as I said previously, uh, if you have like huge number of data points, I think using Canvas would be much better than SVG. uh, for that you need to choose a library which support both Canvas and SVG, so that based on your requirements you can switch between Canvas and SVG. And also it's necessary to avoid any unnecessary re-renders. It might be true for any other components, and it especially true for data visualization, because as I said, it's very compute intensive, right? To draw this particular data visualizations, lot of computations will be happening, and lot of insertions and deletions will happen. So for any re-render might have a huge performance impact. So it's better to profile when you are implementing a data visualizations. It's better to profile the page which has data visualizations and make sure any re-renders or unnecessary re-renders are happening. And if they are happening, try to identify the reasons for that and maybe fix that, so that it will have better performance. I think that's all I have for now. If you have any questions, I'll be happy to take them. Yeah. So before we go, I want to show some things as well. Once again. Yeah. So as I said, Anki is kind of quite powerful in the sense it supports wide variety of charts in the sense it supports maps. Again, as I said, this Antv is not just a single uh, chart, single type of data visualization library. It kind of support whole um range of data visualization. For example, here we can see flow charts, right? And here we are seeing the line charts, and here we are seeing some maps and with interactions as well. Let's see what else we have. And they are very performant in the sense. Again, as I said, this supports both Canvas and it also supports WebGL as well. For example, as I said, especially when you are doing these kind of maps or anything, there can be like it could be huge, right? Even Canvas might not be sufficient. In such cases, WebGL might be better solution. So for these maps, I guess G2 uses WebGL as well. That's good. And what else? Again, these are the standard bar charts. These are the stacked bar charts. Again, the group bar charts. Um, Again, you can see, right? It also supports not just the static representation of the charts. It also supports the interactions as well. Range. What else? Pie charts and the scattered charts. Even this Sankey kind of uh, kind of pointers where thing, funnel charts, word cloud, um, radial charts, and these are the, and we can also do a lot of customizations. For example, let's take something, and we can do multiple views in the sense. For example, um, let's take this. Right. Right. So we were able to put multiple charts on the same, same chart thing. Again, you can see this is so much complex chart, and we weren't doing much code as well. It's mostly configuration. But when some customizations are necessary, we can do them as well. Again, here it is using myths. So myths is where because we are having three types of charts, right? So this G2 has the concept called views in the sense, each chart, for example, in in most cases, we will be just having one type of chart, right? But in this case, we are having three charts. So each one of them, we can call it as a view and combine these three views into a single chart, right? So that's where the myths will have, myths will happen. And the myths will have three plots. You can see, we have like three plots. The first one is bar, the second one is pie, and the third one is area. So we are passing the plots with each one has its own configuration. For example, area plot has its own configuration and the data, and this bar chart has its own configuration, and we are passing these three plots as an array and passing it to the myths, so that the entire thing will be rendered on a single chart, right? Yeah. Yeah, so that's all I have for now. I'm also kind of thinking of creating some demos. Unfortunately, I didn't have ready with them, so I want to take some generic use cases, like for example, some stock market data, or coin market, some cryptocurrency visualization data, or the coronavirus. So I want to take a few demos which we generally encounter on daily, day-to-day basis, and implement them with G2. I'll try to do them over the next week, and maybe uh, send the code for all the people who register for this workshop, right? Maybe next week. Uh, yeah. So yeah, you can reach out to me if you have any questions. You can reach out to me on Twitter, or even leave a message on meetup.com. Uh, okay then. If you don't have any questions, we can close the session. So it was kind of short. I mostly want to uh, show the different comparisons, especially because I was very surprised in the sense, when I started doing the research for this data library, and I was searching through the internet and reading the blog posts, and watching the videos and everything, and I never encountered this Antwi. I mostly, when I was googling, I was mostly finding articles about D3, and I was mostly finding articles about Nivo, this kind of React wrappers, but I never encountered any blog post on Antwi or G2 or anything. Mostly because it could be because it's coming from the China team, and the SEO is not good in India or something, or outside China or something. For some reason, I couldn't find these about these libraries, and one of my colleague uh, introduced me to this G2 he used in another project. So then I came to know about G2, and I explored, and kind of, it worked really well. It's kind of exactly the library we want. And yeah, so I thought, okay, I will share what I find with people also, because especially, picking the right library itself is kind of a huge milestone, right? Especially when you pick a good library, and if it helps you a lot, um, yeah, things become lot easier. So that's the case in our case as well. So we were able to make good progress on our project because we picked Antwi. In Antwi, we were able to, for simple charts, we were able to create them very quickly. And when we need some customizations, those things as well, we were able to do them. If we have started the project with D3, it will be much more trouble for us because it's very low level. Uh, Unlike D3, G2 has kind of whole range of uh, abstractions. It has low level, it have mid range, it has higher level. So it kind of have whole range of abstractions which are kind of helping out us in building the data visualizations quickly. So I thought, okay, it will be good for the community also to know more about this Antwi libraries. And yeah, you can also go through the examples they provide, uh, especially the Antwi. Uh, they have like very interesting examples. I think the example going through the code, and let's see. Yeah, you can go through the code along with the examples. The code will also be there. So by going through the code itself, you can learn a lot. Yeah, you can go through the examples, and uh, and go through the code, and you can learn quite a lot by going through these examples as well. And more than the documentation, that's what I do. Whenever we have a requirement, the first thing I do is go through the entire examples page, and see what uh, kind of what we need. For example, let's say I have a requirement for some this kind of chart where we have a bar chart, on top of that we want a line chart, right? And I can quickly look into this code, and take the code and customize it to my own requirement. So Yeah, going through these examples will be very helpful. Okay, then we'll close the session, and I will send you the link for the slides and some of the demos I will create also. Maybe I'll send 1 week later, uh, along with the demos and the slides all together. And meanwhile, if you need anything, feel free to reach me on Twitter or Meetup or anywhere. Yeah. Thanks again for joining this. See you again in our next event. Bye, everyone.